Hello, everybody. Thank you, Kyle, and thank you, Thermo, for the invitation. You can call me Leondios, like everyone else, is simply. First time I visited Bremen was in 2001. It was just after the dioxin crisis in Belgium, and I was started to organize a dioxin lab in Greece. So it was my first contact with dioxin people. And if I remember well, Peter first was chairman in one of these sessions, a long time ago. Times passed, and now the mass spectrometry dioxin analysis lab is the national reference lab for Greece and Cyprus, and also it participates in the network of the labs of the United Nations that Dr. Finder has nicely organized. Of course, he's accredited, and he follows the quality controls and assurance according to EU regulations, as Alex Cox explained us. He has his own in-house methodology, and also he follows international methodologies. And all this year, the lab has established very strict collaboration with official control authorities for food, feed, environment, and health. And also, the laboratory provides support to food companies and producers in Greece and Cyprus. This is the lab's website. This is how the lab looks from outside. It was built in 2001 from scratch to avoid any contamination from previous laboratory activities. And our clean room, the air coming in and out is filtered with carbon and fiber filters. The temperature and the humidity is controlled, and there is always positive pressure to protect the workers. Now, the MAD 95 was installed in 2002 with the end of Frank Theobald, and after 12 years and more than 11,000 injections, it still works nicely. I have spent enormous hours with the instrument. My wife complains about that. And now we are in the process of installing a new instrument, a DFS, and it will be incorporated in the routine analysis after Frank come again in Greece to help me install it. Our method for the extraction, we use standard methods, chocolate and liquid-liquid, and also automated ones with Dionex AC300. Now, for the cleanup, we use our in-house method that take advantage of a special carbon material, carbosphere, that can handle more than 10 grams of fat, and that's important for sensitivity. And also we use the automated system of power press with disposable columns that can take up to 5 grams of fat. Now, we have a TSQ Ultra, MSMS, and also we make some efforts to see if we can measure dioxin with with this instrument. And here you can see some chromatogram. And when we combine this, our in-house method that can take a lot of sample with MSMS, we have LOQs the same order than high-resolution MSMS. And the method is linear. And we have tested in some interlaboratory real samples with high-resolution MS and MSMS, and you can see that is perfect agreement. The only thing is to remain to prove is the robustness of the MSMS, but it will be other talks. I see the program later about the MSMS, so I don't say more. Now, all this year, we have analyzed more than 4,000 samples of food of Greek origin. And the first result was published in 2004 in Chemosphere. And all samples were found to contain much lower dioxin than the maximum limits, and in many cases lower than the European mean concentration according to Sanko report. And that is normal because Greece is not an industrial country, and also we don't incinerate the waste, so it was expected that Greek food are low in dioxins. And also, we determine the levels of dioxin, furans, and PCBs in urine serum and milk of people living in Greece, measuring in Athens and also in some rural area. and also this value were lower than the North European countries, as expected. But we have some problems. In 2006, a fire was broke in a landfill in the north of Greece. The fire took almost a week to put down, and this causing precipitation of contaminated fly ash in the surrounding area. And the area was in quarantine for almost a year. A lot of samples, milk and goat meat and eggs were found to be above the limits. And what we discovered was that elevated percentage of genetical disorders was observed in the goat herds in this area. So this work was also published in Chemosphere. And also in 2007, if you remember, there was massive forest fires in Greece. This is an image from the satellite. And it was a big disaster. And not only forest, but also houses and people were dying in this disaster. And we were involved because we are afraid of what will happen to the olive production of this year, because the south of Greece was a massive olive production area. But we found out that the elevation of the background was very small, and that's because, as you can see, the winds were very strong this period, and the fly ashes went through the sea. So for the people, there was no contaminations for the oil of that years. Now, to finish with dioxins, one of our recent works was to establish the infant dairy exposure to dioxin-like PCBs in Greece. And for that, we calculate the breastfeeding and also the formula milking, milk and the combination of both for child to 0 to 6 months old. And for older children, we also take into account the solid food. But as Peter said, breastfeeding is important for childs. Only thing is has to calculate the intake and take care if there is very big values. Now, enough for dioxins. That was what we are doing normally. But the lab is also studying for emerging pollutants, and perfluorinated compounds are a class of chemicals that came in interest the last years. There are fully fluorinated alkyl chain compound, and they have a charged functional group in one end. And they have surfactant properties, they are amphiphilicity, they are non-flammable, and they have high chemical stability towards degradation and photolysis. Here you can see the acronyms of the main compounds. The carbon chain starts for 4 carbons to 18 carbons, and you have carboxylic or sulfonic acids at the end. Now, the most stable PFCs in the environment and the most studied are PFOS with 8 carbon in the chains and PFOA, and they have been produced in high amounts among several decades in the past. So, due to their chemical properties, PFCs are used in paints, in anti-sticking cookware, in food packaging material, adhesives, tapes, foams, carpets, cosmetics for women, and electronics. PFCs has the high ability to migrate in area water. They transport in long distances. They introduce to food chains and they bioaccumulate, and they have harmful effects in human health. So they have all the characteristics to be considered as POPs. In this sim, we can see how they enter and transport in the environment from the producer plants and the customer produce products, the rubbish dumps. They go through air and through water and through soil, and finally they found themselves in underground aquifer and animal organizations. Now, PFCs found now widespread in all around the environment, in surface water, in tap water, in drinking water, in rivers, in Arctic and Antarctic ices, in grounds, in vegetables, in the sea and fishes, in animals, and of course, in humans. Now, the routes of exposure are more complicated than dioxin because they have this amphiphilicity character. So they enter human body from food ingestion, but also from drinking water, inhalation of dust, inhalation of indoor air. They transfer to embryos from placental and also from breastfeeding. And FOS and FOA have been detected in blood of workers exposed in PFCs in many countries, including Greece. Now, as I said, PFCs are amphiphilytic compounds, and they do not accumulate in the adipose tissue, but they bound to blood proteins, and their target organ is the liver. They have half-life eliminations 4 to 5 years, so they are long lives, and they have harmful effects in the health, as proved in animal studies: hepatotoxicity, neurotoxicity, endocrine disruption, immunotoxicity, and also found in humans and human cells. They have developmental effects and possible carcinogenicity. For all that reason, in 2000, 3M, the main producer of PFC worldwide, announced the phase out of the FOS production. Also, European Food Safety Authority in 2008 published a report that where he had performed a health risk assessment and prescribed a tolerable daily intake. In May 2009, FOS and its salts were added to the list of POPs of the Stockholm Convention with the remark that FOS has the capacity to undergo long-range transportation and also fulfills the toxicity criteria of the Stockholm Convention. And in 2010, EU recommends the member states to monitor the presence of FOS, FOA, and if possible, the precursors for the next 2 years in food in their countries. Now, for measure PFCs, you need a sensitive and selective method, and the method we have developed in the lab use isotope dilution method with the additional of internal standards. For the extraction, we use for solid samples acceleration solvent extraction. For liquid samples, liquid-liquid extractions. The cleanup is with solid phase extraction and the instrumental analysis with LC-MS. Here you can see some steps, the addition of the standards, the grading, loading the cell to the assay. The cleanup with solid phase extraction with C18 cartridges, separation with an LC column C18 as well, and the instrumental analysis is done by LC-MS, operating in ESI negative ion mode, and detection and quantification were performed in multiple reaction monitoring. Here you can see the mass transitions, 2 for every congener, and 1 is for quantification, and the other is for verification. Here you can see a typical chromatogram. And the method is validated for sensitivity, selectivity, specificity, recovery by the use of isotope label standards. Working range, LOD, LOQ was determined, repeatability, reproducibility. And this method has been accredited 3 years now. Some results. Our first interest was to see what happens in the blood of people living in Greece. That's why we take 3 populations, one of people living in Greece, in Athens, sorry, other people living in the country, and also we take a group of cancer patients with diagnosed cancer of stage 3 to see if there is any direct relation between PFCs and cancer. And as you can see from the results, in all 3 groups, men are more they have more PFCs than women, maybe because women are clear with childbirth or the period and everything. Also, there is no difference between people living in Athens and people living in the country, in the countryside. So that means that this kind of compounds are widespread distributed, and they are everywhere. And also, we didn't find any direct correlation with cancer patients. And we think that because we take cancer of all types, so it was not a specific cancer, so that's why we didn't find any correlation. And the mean value that we found was similar than those reported from other European countries, and were at least 10 times lower than the values reported in the USA and Japan, where these kind of chemicals are used much more. The next study, it was to determine the concentration of PFCs, if there are any, in various food packaging used in the Greek market. For that reason, we take paper cups for coffee and cups for ice cream, for fast food, paper box and wrappers, for baking papers, for microwave bags, and also aluminum foil wrappers and boxes to analyze to see if there is PFCs. As you can see, in almost all the materials, there are no detection of PFCs. That means that these kind of chemicals are not very famous, utilized in Greece. Only in a case of microwave bag for popcorn, we find very elevated values, and that means that maybe when the food has to be heated, the companies use more of these compounds to protect the oil sticking of the food to the packaging material. We have analyzed a number of samples and categories of food, meat, pork, beef, lamb, chicken, fish, wild and aquaculture fish, milk, eggs, and vegetables. As you can see, we found very low values. The concentrations measured are in the same range that those reported in other countries. The low levels of phosphine in Greek food samples are probably due to the very limited industrial production and use of these compounds. And from this work, what we find interesting was that only in wild fishes we find elevated values, and in much difference than aquaculture fishes. That's why we think to study more carefully fish. That's why we take samples of lean fish and shellfish from all around Aegean Sea. And also we wanted to see if there is any differentiation of the PFCs during cooking. That's why we analyze the raw fish and also we analyze fried and grilled fish. And as you can see from the results, there are very low levels, and only phosphor were detected in most of the samples. And if we check what happens during cooking, you can see that here there is a decrease of values. One is frying, but this is due of the oil absorptions to the matrix. And also there is an increase of the value where is grilling, and that's because the loss of water. And all these values tell us that these differences are small, so there is no degradation of PFCs during the cooking, except maybe for PFDA. So even if you cook the fish, these chemicals are still there. And with all that, I would like to thank my collaborators for the good work and you for your attention.